Hello, and today we will be discussing binary search, which is a search algorithm that is more efficient than linear search. And for binary search to work, the data in the list must be sorted from either least to greatest or greatest to least. So now let's discuss how binary search works. So let's say we have a 5-element list, just 1, 2, 3, 4, and 5. And the element that we are searching for is, or our target value is going to be 2. So target is 2. And so the way binary search works is that there is a low index, midpoint, and a high index. So first, our low index is going to be our first element, or the element in the 0th index. So in this case, it's going to be 1. So our low index is 1, or our low index is really 0 always. So 0, but the element in the low index is 1, and the element in the high index is just going to be our last element. Or in this case, since we have 5 elements, array.count -1, which is going to be 4. So our low index is 0 and our high index is 4 when we start out. And our midpoint is going to be the point in the middle of the whole list. And in this case, it's going to be 3. So 3 is our midpoint. Now, the goal of binary search is to find the index of the target element, or that the target element exists within the array. And so this is done when the midpoint is equal to the target. So if the midpoint is ever equal to the target, then binary search is finished and it was successful, and it found the target element within the array. But if the midpoint never matched the target value when the algorithm ran, then that means that binary search returned that it did not find the target element within the array. So let's see. Now what do we do? Now we compare the midpoint to the target value. So we compare 3 to 2, and we see that 3 is greater than 2. So this is all good, but now what? Since 3 is greater than 2, now we don't need to worry about any of the points to the right of 3, because we know that our target value is less than the midpoint. So all we need to worry about are the elements from to the left of the midpoint. So what happens is our high point, instead of being 4, it's now going to shift to 1, or the second element. And so now 1 is our high and 0 is our low. And the reason for this is because 3, 4, and 5 are all greater than our target. Any element that is greater than 3 or to the right of 3, because our list is sorted from least to greatest, we don't need to worry about, because our target is lower than all of those numbers. So our target will, or our high index will essentially be the index of our midpoint -1. So it's just going to be right here. This is going to be our new high index, which is 1, which the element in the first index of the array is 2. So now 0 is our low and 1 is our high. And so now we need to find our midpoint of this array again. So now our array that we're examining is only 1 and 2, because 0 is our low and 1 is our high. But there are only 2 elements, so what do we do? In this case, just take to find the midpoint, it's just the low index plus the high index divided by 2. So it'll be 0 plus 1 over 2. And 0 plus 1 over 2 technically equals 0.5. But with Swift, whenever Swift is talking about integers and such, integers do not have decimals. Those are doubles. So it's going to round down and go to 0. So whenever there is a decimal like 0.5, 0.5 is going to round down to 0 whenever Swift is discussing integers. Or, for example, 1.5 will go down to 1. All right, now back to binary search. And so it's 0. So what does that mean? That means we take the 0th element as our midpoint now. So our array is now 1, 2, and we take 1 as our midpoint. So right now, 1 is still our low. It's still our low, but it's also our midpoint. So it's also our mid. But 2, or the element 2, with high index of 1, is still our high index for now. So now 0, the 0th element is our low and midpoint, and now we compare our midpoint to our target value again. 1 is low index and midpoint. But since 1 is less than 2, the low will shift right. So that means 2 will be both low index and high index. And then we take the midpoint of just this array of 2. And the midpoint of this array of 2 is just 2. So it's also a mid. Since it's also a midpoint, we compare 2 to 2. 2 equals 2, and binary finishes and says it's found 2. Now let's take a look at the code, and this might make a little bit more sense. So we have our same array. To better understand binary search, we have our same array and our same target value. And we have a function here, which is just binary search, just taking in 2 parameters and returning a Boolean of either true or false. True if the target value exists within the array, and false if the target value does not exist within the array. And this array parameter right here is just the array, the sorted array that we're passing, and target value is just our target right here. All right. So we have a low index variable that we're setting to 0, our high index, to array.count -1. And in the next line, we have while low index is less than or equal to high index, let mid index equals low index plus high index divided by 2. We get our mid index, and then we say if a of mid index to get our midpoint. So if our midpoint is equal to our target value, then return true. Then it just comes out of this function and returns true, and all is good. It says that the target value has been found within the array. But if not, if the target value is less than the midpoint, then high index equals mid index -1. So what does this mean? Essentially, if 4 is our high index, so 4 meaning the index of our last value on the first iteration is just 4, and 0 is our low index, and our midpoint is 3, and our target value is 2. 3 is greater than 2, so as I said earlier, our array is going to only examine 1 and 2 because 3 is greater than 2. And so that's what's happening here. High index equals mid index -1. That means that high index is no longer 4. It's going to be mid index, which is 2 -1. So 1. So it's going to go from 0 to 1, if that makes sense. So that's the reason why we set high index equal to mid index -1. And then if target value is greater than array of mid index, so say our target value was something like 4, then we would not need to worry about 1, 2, or 3, because 3 is less than our target value. So we'd only need to worry about 4 and 5. So if we needed to only worry about 4 and 5, we would need to set low index to mid index plus 1, right? So that's exactly what we're doing here. We're setting low index to mid index plus 1 in this line right here. And at the end, we have a return false. And this is just in case it never finds a midpoint that's equal to our target value. And that's when it'll return false. And it just means that the target value is not found within the array. All right, so if we run our code, so our mid index is 2, and that makes sense because 0, 0, 1, 2. So the element with index of 2 is 3, or our midpoint on the first iteration. And so that's our mid index 2. And our low is going to, of course, start out with 0, and our high index is going to be 4, as we said. And then our mid index is going to go to 0 because remember how we split the array in half and we only took 1 and 2. So now when we only took 1 and 2, we said that our mid index would be 0 because our mid index would be the index of the of 1 because it's the 0th element. And we said that 0 plus 1 divided by 2 is technically equal to 0. Our low index and our mid index are the same in this case. But then our high index is 1, which has a value of 2. And then our mid index, low index, and high index are all the